Okay, let's start the live session. Okay, so hello students. I hope you all are doing good. I am Sambhav, your senior math teacher, and in this session we are going to talk about statistics. So let's wait for 2-3 minutes so that everyone can join. And let me tell you one thing, if you are having any doubt about this chapter, if you are having any problems in this chapter, you can let us know in the chat box or in the comment section. We are gonna uh, tell you the solution or correct way of dealing with those problems. Okay, now let's wait for 2-3 minutes so that everyone can join. Okay, I can see someone is saying hello sir, hello, welcome. So hello, yeah. Yes, please do join the session. We are gonna wait for 2-3 minutes only, and then we are gonna start the session. In the meantime, you can let me know from where you are and more about yourself so that we can know each other better. So, okay, my name is Sambhav. I am from UP. Please tell me about yourself. Okay, welcome. Yeah, join the session. We are gonna start soon. Don't worry. As we know that we are surrounded by data. No, even if we are watching cricket match, we are looking at different type of data. No, how many runs scored by one particular player, how many runs scored by a team, or how many balls bowled by particular bowlers. Different type of data, correct? If you are working for a company, then you must be seeing different type of data, right? Then if you are an accountant or something, then you are dealing with data, right? So it means we are surrounded by data, and the study of this data to extract the meaningful information out of it comes under the branch of mathematics known as statistics. So let's start the session then. So today we are going to talk about statistics. In short, sometimes we can call it stats, right? Now, before going deep into the topic, let me tell you what are we going to cover in this session, because we divided the chapter in two equal parts. In the first session, we are going to cover these topics. We will be talking about the introduction, of course, then types of data, what type of different type of data you can expect, measure of central tendency, very important, then mean of individual data, mean by direct method, mean by assumed mean method. These are the topics that we are going to cover in this session. Now, in the next session, we are going to cover different topics such as mean by step deviation method, mode, and median. Now, I'm going to show you one table which is going to roughly summarize this chapter. Now, here it is. In this table, you can see that we are having different columns where you can see the headings as mean, mode, and median. And here the row headings are individual data, group data, or ungrouped data. So what is this table about? Actually, we are dealing with different measures of central tendency, mean, mode, median, and we are dealing with different type of data sets also, such as individual, ungrouped, and group data. So how to find the mean of different type of data sets? This is the formula, this is the formula, this is the formula. How to find the mode, or what is the process of finding mode? Then how to find median of different type of data set. So this is the summarized way of writing this chapter. You can easily understand everything from here, but we need to deep dive into the topic. We are going to do that also, but this is the table that is very much helpful for you if you want to look at the chapter at a glance. Now that you can do that from here only. I'm going to pick up every topic one by one in this session. Of course, majorly we are going to talk about the mean only, and that too about direct method and assume mean method also. And mode and median, we are going to discuss these two in the next session. Now, let's start the session. What is statistics? Statistics is the science of learning from data. We are continuously saying that we are surrounded by data, we are gonna extract the meaningful information out of the data. So the science of learning from data so that we can extract meaningful information, so that we can make learn decisions, comes under the branch of mathematics known as statistics. Now I'm keep on repeating the word data, 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 right? What is data then? Data is basically facts or figures collected for study. Simple, easy. Facts and figures that we are collecting for the study purpose. This is data. Now, there are certain stages that you are going to deal with when you are working with data, or you want to make decision based on data. Then there are certain stages. First one would be the collection of data. Of course, if you want to study about data, you must be having data, right? So you must be collecting data, maybe from a primary source, secondary source. It can be a different thing, but first thing is the collection of data. Second one would be the organization. Data in raw form can be sometimes very much uh, not usable. So we are going to do one thing. We are going to organize that data, maybe in a particular order, ascending, descending, maybe in tabular format or something. But of course, we need to organize the data to make the meaningful, to get the meaningful information from it. Then presentation of data. We need to present the data. Then analysis. Of course, we are going to do the analysis at the end. Now, these are four main stages in statistics. Let's deal with some other things like how to find mean, mode, and median. Before that, we need to understand how many types of data we are going to deal with. See, there are basically three types of data. First one would be individual data or raw data. So, individual data is like we are having individual observations, right? Suppose data is very small and we can deal with each observations. So that type of data is known as individual data, usually known as raw data, the data that is coming as it is. Then we have second type, that is ungrouped type of data. Ungrouped type means that each individual is repeated certain number of times. So we are doing one thing, we are writing it in a tabular format where we are writing each individual observation in either column or row wise, and then against it we are writing how many times it is being repeated in terms of frequency. What is the frequency of that observation? Then we have group data. Now suppose we are not able to write each individual observation. There are too many observations and we are not able to write each individual observation. Then we are gonna convert the data into grouped format. That way we are gonna create class intervals, and in that particular class interval the frequency against it. We are gonna write it in that way. So we are gonna deal with all three of them. I'm gonna tell you how to find different things, mean, mode, and median, depending on what type of data you are having. So I guess someone is asking why we are working with different types of data sets when we can do our analysis based on individual data. Great question. See, whenever we are having data, we are getting data from somewhere. Initially, it is always individual values or individual observations. So it is always raw data. We are the only ones who are converting them, these observations, into either ungrouped or discrete data or grouped continuous data. Why are we not dealing with individual data only? First thing first, individual data, the calculations that are being done on individual data is very accurate. That is true, but it is time consuming. Suppose if we are having limited number of observations, then it is feasible. But if we are having a more number of observations, then we need to convert the data accordingly. If we are having limited, more than limited, but somewhere in between, then we can convert it into ungrouped data, but keeping in mind that the observation, individual observation, should be limited. Then if we are having unlimited observations, individual observations, and that too are being repeated multiple number of times, or you can say that thousands or more than 1,000 entries are there, then we need to group the data. So to save our time, we are going to convert individual data in different forms according to our need or according to the type of data we are having. So that is the need actually. Now let's talk about each of them one by one. First is individual data. As I told you, individual data is nothing. It consists of raw facts or figures that you are getting from somewhere, separate observations, individual observations, exactly as they were collected. How you are collecting them without any order or summary. There will be no particular order. Of course, you can reorder them. Now, it is used when the data set is small enough that every single point can be listed individually. This data set is only useful when we are having limited number of observations, when you can easily or carefully observe them, you can do analysis on them. Like for example, here, what is given to us? The weight in kg of 5 specific students in a gym class are 45, 52, 48, 60 and 55. Now these are the individual observations. How many of them are there? 5 only, right? Limited number of observations. So we can easily deal with them. If I want to find the mean, mode or median, I can do that easily because there are limited number of observations. There is no need to convert them into ungrouped or group type. Why? Because there are only 5 observations. We can deal with them. But suppose if we are collecting the data of more number of people, suppose if there are hundreds of contestant or hundred of students are there for which we are collecting the data or weight, then it will be difficult for us to do the analysis based on each individual observation, correct? So that's why in that case we are going to convert our data into either ungrouped or grouped. Now let's talk about ungrouped data. What is ungrouped data? Till now we have seen 5 observations only, but suppose if we are having certain type of data where observations are limited, like observations are 10, 15, 12 and 7 only, 4 observations are there only, but they are being repeated multiple number of times, like 10 is there 4 times, 15 is there 5 times, 12 is there 2 times and 7 is there 3 times. So then we are gonna convert that type of data into ungrouped. For you, examiner is gonna give you the data as it is, like in this format. You need to deal with this only, but you need to visualize from where this data is coming. This data is nothing but the individual observation where you can see 10 is being repeated 4 times. So it will be like this: 10, 10, 10, 10. Then we can see 15 5 times. 15, 15, 15, 15 and 15. Then 12 2 times, 12, 12 and 7 3 times, 7, 7. So this is the actual individual data, but we can see na that the same observation is being repeated multiple times, so we can convert this type of data in tabular format or grouped one. Now we have third type of data, that is group data. When we are having more observations, and that too that the individual observation is not being repeated multiple number of times, but we are seeing multiple observations, and that too in suppose hundreds or thousands, then what to do? Then we can only convert the raw data into grouped one, so that we can save our time. So here what are we going to do? We are going to create class intervals here. Suppose in this example, we are organizing these exam scores of 100 students into frequency table. So here we are writing in the first row, we are writing the marks scored by students, but in a particular range. All the students who are in between 0 to 20 will come under this class interval. Whoever is scoring in between 20 to 40 will come under this class interval. Now, you can ask me one thing, that 0 to 20, 20 to 40. So where should we be putting the student who's scoring exactly 20? See, 0 to 19, okay, understandable that they are here. But if someone is scoring 20, we should be putting in this class interval or in this one. If we are including that student in both the class interval, then we are not creating the correct table, right? So he should be included once only. So where should we be putting him? So if 20 is written in upper class limit, see class intervals is showing two values, no? 0 to 20. So 0 is the lower class limit and 20 is the upper class limit of this particular class interval. So if 20 is the upper class limit, then you will not include 20 here. If 20 is the lower class limit, then you can include it here only. So lower class limits are included, upper class limits are not included in case of continuous data. Understood? Now, whoever is scoring in between 0 to 20, they are here. So the frequency or the number of students who scored in between 0 to 20 are 5. Number of students who scored between 20 to 40 are 15. Now let me ask you, how many students did scored in between 60 to 80? Please let me know in the chat box. How many students did scored in between 60 to 80? Right, 30, because the frequency here is 30, correct? 60 is included here, but 80, whoever is scoring 80 is not included here. Very good, everyone. Now, this is about different type of data set that you will be encountering. Now, how to find different values such as mean, mode, median? Let's talk about it. So, first thing, we need to understand the measure of central tendency. What is measure of central tendency? What is the meaning behind this measure of central tendency? Measure of central tendency refers to a statistical value that represents the center or typical value of a data set. Suppose if we are having a data set and if we want to understand where it is lying, what is the central value of this data set, then that we can find using measures of central tendency. So basically there are three methods, or there are three measures of central tendency: mean, median and mode. Now mean is nothing but the average of that data set, those observations, the average of those observations. Then we have median. Median is what? Median is the middlemost observation of that particular data set. Then mode is nothing. Mode is that observation which is being repeated maximum number of times. Now, someone is asking in the chat box, I just saw a very good question in the chat box, that why we are having three types of measures of central tendency. Again, excellent question. You should be asking this. Why we are talking about three measures of central tendency? If we are saying measure of central tendency is nothing but the centrally aligned value of that particular data set, where the data set is lying centrally, right? Then why we are having three of them, three measures? Okay, let me tell you this. Mean is the average, no, of all the observations. So mean is basically including all the observations in that particular data set. So that is the good thing about mean. Then what is the bad thing about mean? That mean is including all the observations of the data set. Now you must be thinking that, are you kidding? Are you joking? You are telling that this is the strength, this is the weakness. Why? Okay, let me tell you one thing. See, if data is distributed normally, if the values are not scattered in very large amount, if the data set is distributed normally, then mean is the perfect tool to use. Mean is widely used because it is including all the observations in the data set, correct? But suppose if the data is not distributed normally, if we are having very extreme values, suppose majority of the values are in between 10 to 20, but there are 2-3 values which are greater than 50, then those three values are gonna give us the wrong mean of that particular data set, correct? That will be wrong mean because that will not be the proper central value, because we are including every value na in mean. So that's why these extreme values can give us the wrong idea about the data set. In that case, what should we be doing? We should be considering median in that case, because median is nothing but the middlemost observation of the data set, correct? Then in that case, median is the perfect tool to use. Then where should we be using mode? Mode is nothing but the observation that is being repeated maximum number of times. Suppose I am a shopkeeper, I do sell shoes. If I am great with statistics, then I will do one thing. I will ask my team that create a data set that which shoe size we are selling more, so that we can order those shoes only, that number only. So this is what? This is finding the mode, which shoe size we are selling more. That will be the maximum frequency, of that particular shoe size. So we can order that shoe size in maximum amount so that we can increase the profitability, or we can also increase the decrease the losses. Because if some shoe size we are not selling more, why order them? Correct? So mode is useful there only when we are dealing with categorical data. Now let's talk about each of them one by one. The first thing is mean. As I told you, mean is nothing but the average. So you have been using mean knowingly or unknowingly throughout your life. You have been using this mean. Everyone is. The basic formula to find mean is sum of all observations divided by number of observations. Now I told you that in case of mean, we are including all the observations, right? So we are gonna find the sum of all the observations, and then we are gonna divide that by number of observations. How many observations are there? That will be the average of all those observations. Correct? How you are using it? Suppose you are getting your report card and there are 5 subjects, science, math, social and everything. So you must be getting different marks in different subjects, no? So in some subject you must be getting 98, in some 80, 85. So that could be anything. To find the mean marks or the average marks scored by you, you can do one thing. You can find the sum of all the marks scored by you, and you can divide that by total number of marks. Not the total number of marks, how many subjects are there? 5. That will be the mean marks scored by you in each subject. Correct? And you have been doing this, no, from a very long time. Yes. Now this is basic idea behind mean, but depending on different type of data set, we can have different approach to find mean. Okay, let's understand them one by one using some examples. First, we are going to find the mean of individual data. The formula will remain the same, that we are going to find the sum of all observation. Usually, or the correct way of representing, or the mean can be denoted using x bar, x and a bar over x. So this is the representation of mean. How to find x bar, or why we are using x bar only? Because we are representing each observation with x1, x2, x3 and so on, depending on how many number of observations are there. First observation would be x1, second observation would be x2, then so on till xn. N means how many total number of observations are there. So the x bar or the mean value can be found out using this formula, x1 plus x2 plus x3 and so on till xn divided by n, the total number of observations. X is representing observations, n is representing number of observations. Basic formula. Now let's apply this. In this example, we need to find the mean of these observations: 5, 7, 9, 11, 13. Okay, already written in the ascending order, no? Looking good. Now, in this data set, we are having limited number of observations, 5 only. We can easily deal with them. So that's why this is individual data. Each observation we are dealing with individually. Now to find mean, we need to do what? We need to find the sum of these observations. Let's do this. So x bar would be 5 plus 7 plus 9 plus 11 plus 30, and we need to divide the sum by total number of observations. How many observations are there? 1, 2, 3, 4 and 5. So divide by 5. 5 plus 7, 12, plus 9, 21, plus 11, 32, plus 13, 45. So the sum of all the observations is 45, and we need to divide this by 5. What is 45 by 5? 9. Thank you. So the mean of all these observations is 9. Now let me tell you one more thing about mean. As mean is the average of data set, no? So the mean value will always lie in between the lowest and the highest value. It can be any value, it can be in decimals also, but it will always be in between the lowest and the highest value. It can never be lesser than 5, it can never be greater than the highest value 13. For each data set, what is your lowest value, what is your highest value, the mean will always be in between those two. So in this case, we are getting 9. So 9 is the mean of this particular data set. But here we are dealing with each individual observation, and that too in very limited number. No. Now let's move on to next data type. That is ungrouped data, but we are having frequency distribution here. Frequency distribution table usually tell us how many times a particular observation is being repeated, how many number of times. Here in this data set, we can see two rows. The first row is telling us the the observation, individual observation, like 5, 6, 7, 8 and 9. And the second row is telling us how many times that particular observation is being repeated. That is the frequency of that particular observation. So 5 is being repeated 4 times, 6 8 times, 7 14 times, 8 11 and 9 3 times. Now how to find the mean of this type of data set? First, we are going to convert this table into a vertical format like this. So same, we are going to do the same thing. We are going to write the observation in the first column, frequency in the second column. Now third column, we are going to calculate. Why? In case of individual observations, we are directly finding the sum, correct? But here 5 is being repeated 4 times. So the sum of all the observations that are 5 will be what? 5 plus 5 plus 5 plus 5, that is 20. Or directly I can do one thing, I can multiply this 5 with the frequency 4. So it will be 5 into 4, 20. So in this column, I'm gonna write those values only. Name of this column is Fi into Xi. Why I? What is I in superscript? In subscript, sorry. I represent that for which observation we are talking about. We are talking about the first observation, no? And the frequency of the first observation. So this is gonna give us F1 into X1. If we are talking about the second observation and second frequency, then F2 X2, F3 X3, F4 X4, like this. So I is basically the representation of for which observation we are talking about. Now 5 into 4 is 20. Then we know in the data set 6 is being repeated 8 times. So basically we are adding 6 8 times, or directly we can do one thing, directly we can multiply 6 with 8. What is that? 48. Then 7 is being repeated 14 times. If you have to deal with these observations individually, then it will take more amount of time, no, to find the sum and everything, and the data will take more space and it will not look good, but the table is looking good, correct? That is one more advantage. 7 into 14 will be what? That will be 98. Now 8 into 11, 88, easy. So we are dealing with 8s, right? Now 9 into 3, 27. Now in case of each individual observation, we are finding the sum directly because we know the each individual observation. These are the sum of each individual observations. This is the sum of all the 5s. This is the sum of all the 6. But these are sum of each individual observation, no? And we need to find the sum of all observations. So how we can do that? Now we are gonna sum these values. Here we are gonna write the sum, and that is known as summation Fi Xi. This is a Greek symbol, summation. This means that you are finding the sum of all these values. Now 20 plus 48, 68 plus 98 would be 164. Then 88 would be 152 and 27 would be 281. Yeah, 281. So the sum of all the observations is 281. But in mean, we need two things: sum of all the observations, and we need to divide that value by sum or a total number of observations, right? What is total number of observations? How to find the total number of observations here? Usually we do one we do make one mistake. We do find the sum of these values, that is 5 plus 6 plus 7 plus 8 plus 9, but that is not the sum of all observations, or sorry, that is not the total number of observations. Why? Because the value of x or this column is representing each individual observation. How many times they are there in the data set is the frequency, correct? So the total number of observations we can only find using this column. So now we are going to find the sum of all these values, and that is known as summation fi. Okay, what is summation fi? 4 plus 8, 12 plus 14, 26 plus 11, 37 plus 3, 40. So there are total 40 observations, and the sum of those observations is 281. Now easy, we need to apply the formula for mean, that is x bar is equals to summation fixi divided by summation fi. Summation fixi 281, summation fi 40. If you divide them, you will find the value as 7.025. No, I'm not human calculator. I already calculated the value once, so I do remember this. So this is the average of this data set where we are having ungrouped type of data frequency distribution table. So this is how you can find it. Very easy, right? Easy steps. Now we are going to talk about the mean of group data, but before that, let's take 5-minute break. Okay, I will come back in 5 minutes. Okay, we are done with the break. Now let's continue. So till now we understood the basic concept of mean, how to find the mean of individual observations or ungrouped type of data, right? Now let's continue our discussion and let's find the mean of grouped data. So in case of group data, we can expect observations where we are having limited number of observations, low number of frequency, but then we can have large number of frequency, then we have even larger number of frequencies. So that's why we do have three methods to find mean of group data. Method number one is direct method. In direct method, we are going to directly apply the formula, or after finding certain things, we are going to directly find the value of mean. That's why the name is direct method. Then there is assumed mean method. As the name suggests, in this method, we are going to assume a mean at first, and then we are going to utilize that assumed mean in some way to find the exact mean. Very interesting, right? I'm going to tell you how to use this. Then we have step deviation. Here also we are going to use some value to uh, just make our work easy. Why we are having three methods? Someone is asking, can you explain why three methods to find mean of group data? Excellent question. See, sometimes the values are not large, so we can directly use direct method. If values are very large, then we can use assumed mean method, so that we are not doing the wrong calculations. When values are large, no, then there are higher chances that we can do calculation errors. To eliminate this, we are gonna use assumed mean method. Then if we have more values or even larger values, we can go with step deviation. Each method is nothing but the upgraded version of the previous method. Assumed mean is nothing but the upgraded version of direct method. Step deviation is nothing but the upgraded version of assumed mean method. Why we are using them? So that we can lower our chances to make calculation errors. They are gonna take more time. Each method, upgraded method, is gonna take more time than the previous one, but using them is gonna help you in finding mean, and that too without doing any calculation error. You are gonna understand them each method one by one. They are very easy. Don't worry about them. Now, first method is direct method. When to use it? First thing, we can use it when class intervals are small. I told you that in case of group data, we can expect class intervals, correct? When class intervals are small, relatively small, then we can go with this method. When calculations are simple, when calculations are easy, then also we can go with this method. These steps would be, first we are going to find the class mark. What is class mark? Class interval, I understood. What is class mark? See, whenever we are having a data which is divided in class intervals, so it must be like this: 0 to 20, 20 to 40, 40 to 60, like this, correct? Then every individual observation which is in between 0 to 20 must be included in that particular class interval, right? Now, we don't know exactly. Suppose the frequency of 0 to 20 is 5. We don't know which 5 observations are those. It can be 1, it can be 10, it can be 20, not 20, it can be 19, it can be 14, right? We don't know the exact observations. So, which value to go with? Because class interval is a range. We cannot directly multiply class interval with the frequency, no? So, we are going to assume in the case of group data that the central value of each class interval is the value. Now we are going to multiply that value with frequency. So this is not going to give you the exact mean. If you would have found the mean using individual observation, that is absolutely bang on correct. But in this case, maybe it is not that accurate, but it is relatively similar to the exact mean. So we are going to assume that the central value of each class interval is the observation. That value we are going to multiply with frequency. So class marks are nothing but the middle value of the class interval. After finding class interval using this formula, that is upper limit plus lower limit by 2, mid value we can find using this method, no? Upper limit plus lower limit by 2. After finding this, we are going to multiply frequency with the class marks, because we need to find the sum of all observations. That we can do using this one, frequency into class marks. Then we are going to use the same formula, summation fi xi divided by summation fi, that is x bar or mean. Easy. Now let's apply using one example. In this example, I am using very limited number of class intervals, so that you can first understand this. Then we are gonna move on to a hard example than this one. So there are only 3 class intervals, 10 to 20, 20 to 30, 30 to 40. The frequency or observations that are falling in between 10 to 20 are 5, in between 20 to 30, 9, and 30 to 40, 14. Now, first thing first, I'm gonna convert this table into the vertical one, like this. First column will tell me the class intervals. Second one is gonna tell me the frequency. I'm gonna write fi with frequency. Then I need to first calculate the class marks of each class interval. What are class marks? Upper limit plus lower limit by 2. So 20 plus 10, 30 by 2, 15. Now here I'm gonna write 15. Then we have 20 to 30. So 30 plus 20 by 2, 25. 40 plus 30, 70 by 2, 35. Now you can observe one thing here, that each next class marks is nothing but the adding 10 to the previous one. Correct? So there's a trick. If the class width or width of the class interval is same, like in this case it is 10 only, then you can directly add 10 to the next previous value to get the next value. Now, if you are not comfortable with this method, then you can directly apply the formula upper limit plus lower limit by 2. That is accurate. Now, after finding the class marks, we need to find what? Sum of all observations. Correct? So we are assuming that each observation is somewhere around 15 in between this class interval. In between this class interval, every observation is around 25. To find the sum of all observations, we need to multiply fi with xi. Correct? So I'm going to create one more column, that is fi xi. What is 5 into 15? 75. I'm going to write here. Then what is 9 into 25? 225. Then what is 14 into 35? Okay, I don't know correctly, but I did the calculation, 490. Now, to find mean, we need to do what? We need to find the sum of all observations. These are the sum of each individual observation, correct? Now, to find the sum of all observations, we need to find summation fi xi. So that would be 490 plus 225 plus 75. 225 plus 75, 300 plus 490, 790. Now, we need one more thing, total number of observations, and that we can find using summation fi. So, summation fi. 5 plus 9, 14 plus 14, 28. To find the mean, now everything is clear to us. To find mean or x bar, the formula is very easy. Summation fi xi divided by summation fi. What is the value of summation fi xi? 790. What is the value of summation fi? That is 28. What is 790 by 28? I did the calculation already. That is 28.21. So this is the mean of this data set. So we are finding the mean of group data using direct method. Why this is known as direct method? Because we are directly applying the method. We are finding the value of xi, finding the value of fi xi, calculating summation fi xi, summation fi, dividing them, finding the mean. Direct. Correct? Easy, very easy. No? Now let's move on to a little hard example. Here we are having multiple class intervals. 1, 2, 3, 4, 5, 6, 7 class intervals, and their respective frequencies are given. Now, how to find the mean of this data? So in this problem, what is given to us? A survey was conducted by a group of students as a part of their environment awareness program. Very good. In which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of plants per house. Okay, this is a good survey. They should be encouraging everyone to plant trees. So please do that. Now, this is the survey, this is the data that they have collected. So here in first row they are writing number of plants. So 0 to 2, how many houses do have only 0 to 2 plants? One house. 2 to 4, 2 house. 4 to 6, 1, and so on till 12 to 14, and there is only 3 houses. Now this is the data. How to find mean of this data? First thing first, I'm gonna convert this table into the vertical manner like this. So class intervals in the first column, frequencies in the second column. Now we are gonna calculate the class mark. Class mark you understood? Please let me know how to find the class mark. Someone is already writing in the chat box that we can find it using upper limit plus lower limit by 2. Excellent. So upper limit plus lower limit, 2 plus 0, 2 by 2, 1. 4 plus 2, 6 by 2, 3. 4 plus 6, 10 by 2, 5. And so on. If you realize, it is the middle value of all the class intervals, because we are only having 2, 3 values, no? So the middle one will be the our class mark. So 7, 9, 11, 13. Like this. Now after calculating the class mark, we need to find the value of summation Fi(xi), but before that we must be calculating Fi(xi), correct? Now let's do this. So for that we need one more column, Fi(xi). So these are Fi values, these are Xi values. Multiply them. 1 into 1, 1 only. 2 into 3, 6. 1 into 5, 5. Then 5 into 7, 35. Then 6 into 9, 54. Then 2 into 11, 22. And then 3 into 13, 39. Now to find the mean, we need two things, summation Fi(xi) and summation Fi. Let's do find the sum. So summation Fi, 3, 4, 9 plus 6, 15 and 5, 20. So summation Fi is 20. What is summation Fi(xi)? 7 plus 5, 12 plus 13, 47 plus 50, 97 and 4, 101 plus 22, 123 and 39, so 162. So summation Fi(xi) is 162. Now we know both the values. Only one thing, we need to calculate x bar, that is summation Fi(xi) divided by summation Fi. Summation Fi(xi) 162, summation Fi 20. 162 divided by 20 is 8.1. Easy. So this is your mean. So mean of this data set is 8.1, and we are using direct method to find this mean. Why we are using direct method? Because the class intervals are not too very large values, correct? And the calculations are relatively easy. That's why we are using direct method. So we understood the direct method. Please give me thumbs up or anything in the chat box. Okay, sir, understood. Okay, then everyone understood the direct method. Now let's move on to assumed mean method. So when to use assumed mean method? First understand this. When class intervals are relatively large, then we can use assumed mean method. When values are very big, then also we can use assumed mean method. When direct method is lengthy or calculations are difficult, then also you can use assumed mean method. Here we can take a convenient value as assumed mean. So here we are gonna, as we know that the assumed mean or mean of any data set will be a value which lies in between the two extreme values, correct? The upper and the lowest value and the highest value, correct? So we are gonna assume one value to be our mean at first. Usually we do take the central value of the data set. I'm gonna tell you which one. If you want to choose any value out of that column, that is also fine, but usually we go with the central value. Now, let me show you how to apply this method. The formula of this method would be x bar, the mean, equals to a plus summation fi di by summation fi. Okay, now some new terms, no? Okay, what is a? A is the assumed mean that we are assuming from the table itself. So this value is already there in the table. Do not worry. Summation fi di by summation fi. What is di? Di are the values of deviation. Whenever we are assuming a mean, then we are gonna find a column or values in a column named as di, which is gonna tell you what is the deviation of other values from the assumed mean. This you will understand using an example, but for now understood that di is representing the deviation. How to find di? This is the formula xi minus a. Xi we will be having the class marks, a value we are assuming from that class marks only. Okay. Now let's move on to example before you lose your mind. Now find the mean using assumed mean method. This is given to us. The table is given. I'm using very short table so that you will understand this easily. Then I will show you a good example on this. The class intervals are 40 to 50, 50 to 60, 60 to 70. Now the frequency of 40 to 50 is 5 and the frequency of 50 to 60 is 10, 60 to 70 is 15. First thing first, we are going to convert this table into vertical manner like this. Now the class intervals are written here, frequencies are written here. We need to calculate class mark. What is the formula? Upper limit plus lower limit by 2. 50 plus 40 by 2, that is 45. 60 plus 50 by 2, 55. 70 plus 60 by 2, 65. Now we know the class marks. Here I'm gonna do one thing. We need to assume the mean, no? We need to assume one value to be our mean. Mean will be a value in between these values only, correct? It can be in decimals also. We don't know the exact value. But for now, my understanding is that the mean will be a value in between these values. Now I can do one thing. I can assume one of the values to be my assumed mean. Usually we go with the center value. In this case, I am going with 55. So I am gonna assume 55 to be my assumed mean. So this is a value now. If you want to go with 45 or 65, that is also fine. That is also fine, no problem with that. But usually we go with the center value. Now we are gonna find or we are gonna create one more column now. That is di column. This di is gonna represent deviation. Deviation from what? Deviation of each class mark from our assumed mean. How much it is deviated? Suppose we have assumed 55 to be our mean, no? Assumed mean. So this 45 is lesser than 55. So we are gonna find the difference of these two values. That's why the formula is xi minus a. Now we are gonna find the di values xi minus a. What is the xi value here? 45. Minus a means 45 minus 55. 45 minus 55 minus 10. Correct? Now for this xi minus a, 55 minus 55, 0. And here 65 minus 55, 10. Now in our formula, we are finding the mean of deviations. Now suppose if we need to find the mean using summation fi xi, then we need to multiply 5 with 45, 10 with this with this, correct? Then we need to find the values of summation fi xi. This time we are not calculating summation fi xi, but we are calculating summation fi di. So we need to multiply 5 with minus 10. 10 with 0 and 15 with 10. This will be a lesser calculation, no? Easy calculation rather than calculating FI/XI, correct? So that's why we are moving on to assumed mean method. Whenever we are thinking that the calculations are not easy, we are gonna make them easy like this. Now, again, if we need to multiply Fi di, we need to create one more column, that is Fi into di. Now multiply Fi and di. 5 into minus 10, minus 50. Please do keep in mind the signs. This is very important. You cannot leave negative sign behind. You need to include that. 10 into 0, 0. Of course, any number multiplied with 0 is 0 because 0 is a black hole. 0 can consume anything. 15 into 10, 150. In our formula, the x bar value, the mean can be found out using the formula a plus summation fi di by summation fi. We are having all the values of fi di. Now sum them. So what is summation fi di? Minus 50 plus 0, minus 50. Minus 50 plus 150, 100. So the sum is 100. Now we need one more value, that is summation fi. So what is summation fi? 5 plus 10, 15 plus 15, 30. According to our formula, we need three things. A, in this case, A is 55, summation fi di, summation fi. We know everything. Let's move on to formula. X bar is A plus summation fi di divided by summation fi. A is 55 plus FID, summation FIDI 100 divided by summation FI 30. 0, 0 cancel, 10 by 3 is 3.3333 and so on. So we can stop here till 2 decimal places. So 55 plus 3.33 is gonna give me 58.33. So this is your mean. This is the mean of your data set. Easy, a relatively time consuming method than the previous one, but this method is gonna make your calculations easy, right? Now let's see one more example. In this example, we are considering a large data set than the previous one. We need to find the mean of this data set, and we are gonna use assume mean method here. So data regarding the weights of students of class 10 of a school is given below. And now let me tell you one more thing. This problem did appear in the board exam once. So that's why I included here. All the problems that we are solving did come in the exams. Already they did appeared in the board's exams. Now, weight in kgs are given here in the first row, and there how many number of students do fall in that category is given here. Now this is the raw data, or not the raw data, this is the frequency distribution table of group type. Now we need to compute the mean weight of these students. First thing first, we are gonna do what? We are gonna do what? Yes, we are gonna convert this table into vertical format like this. Class intervals, frequency, then we need to calculate class mark. Again, the upper limit plus lower limit by 2. 52 plus 50 by 2, of course it will be 51. 52 plus 54 by 2, 53. So on till 55, 57, 59, 61, 63. Right? Now we know all the class marks. Then what? We need to assume one value to be our assumed mean. As I told you, usually we go with the central value. How many observations are there, or how many values are there? 1, 2, 3, 4, 5, 6, 7. Odd number of observations. So we can directly choose the middle one, fourth one. So I am going with 57. 57 is my assumed mean now for this example. Now, if we are having our assumed mean, we need to calculate what? The deviation of each class mark from that assumed or di value. So di would be xi minus a. Now let's calculate each value. Xi means these values minus a, the 57. So I'm going to circle it so that we can remember this one easily. 51 minus 57 minus 6, 53 minus 57 minus 4, 55 minus 57 minus 2, 57 minus 57 0, 59 minus 57 2, 61 minus 57 4, and for this one it is 6. Now let me ask you one thing. Calculating FI/XI is easier or calculating FI/DI is easier? This value is easier, no? So that's why assuming method is easier in terms of calculation. Maybe it is taking a little bit longer time, but this is making my calculations easier, no? So why stick with direct method only? You can switch to assume mean also. Now in this method we need what? A value, because according to formula a plus summation fi di divided by summation fi. So now we need summation fi di. So for that we need to create one more column, that is fi into di. So multiply fi with di value. So 18 into 6 will be 108, but with a negative sign, minus 108. 21 into 4 is 84, but in the negative sign. 17 into 2 34, but minus 34. And 28 into 0 0, black hole. 16 into 2 32, 35 into 4 140, 15 into 6 90. Now we are having all the fi di values. We need to find the sum of these values. So please do find the sum, and the sum will be around, I know the, because I did calculated the values once. Let me tell you, the sum is 36. So summation fi di is 36, only 36, because we have some negative values also, correct? So summation fi di is 36. Please do find the summation fi also. Why? Because we must be needing this. So after finding the sum would be 150. Summation fi is 150. This is the first time we are saying summation fi greater than summation fi di or summation xi, correct? Fi xi. So that's why this is exciting, because we are having some negative values now. So that's why it is coming around this much, 36. Now we need to apply the formula. That's why we are taking the central value, so that we can lower the summation value. If you are taking suppose extreme values, either 51 or 63, then you must be having a larger value, but that will depend on the positive and negative sign will depend on what values you are choosing. Now we need to apply the formula, correct? The formula is very easy. X bar is equals to summation fi di by summation fi plus a, correct? Now what is summation fi di? 36. What is summation fi? 150. So let me erase this so that we can directly write the values here. Let me erase this, and then I'm gonna add a with that value. So 36 by 150 plus value of a, we choose 57, no? 57. 36 by 150 I did calculate it, comes around 0.24, and 0.24 plus 57 is gonna give us 57.24. So this is your mean now. This is the mean of this data set. This is how you can calculate it. Very easy method, very convenient to use, and the calculations are not that much difficult, correct? Because we are calculating the deviations, no? So that's why it is very easy. It is taking 2 or 3 more steps, but we can manage that because we are reducing our calculation time in the end. That's why. So that's all about the direct method and assumed mean method. In the next session, we are going to talk about the third method, that is step deviation method. When to use it and everything I will tell you. For now, let's see what we understood in this session. So we did understood the introduction of statistics, then we saw the different types of data with the examples, then we saw measures of central tendency, mean of individual data, mean of ungrouped data, mean of group data by direct method, and mean by assumed mean method of group data. So we understood everything. Now let me again show you the table, this one. So here in this table we did cover this portion except one method, that is step deviation, and these two are remaining. So we are going to understand these two also. So for now we are done with this session. We'll meet you in the next session with some amazing tips and tricks. So for now I will take your leave. Thank you for joining the session. Bye bye from my side.